Climate modeling. Understanding Earth's climate and anticipating change. Climate modeling is a field that plays a vital role in understanding the Earth's climate and the potential impacts of climate change. Math is an essential tool used in climate modeling, from understanding the underlying physical processes that drive climate to analyzing historical and current data to make predictions about the future. Climate models use mathematical equations to simulate the behavior of the Earth's climate system, including the atmosphere, oceans, and land surface. These models take into account a variety of physical and chemical processes, such as the absorption and radiation of energy by the atmosphere, the circulation of heat and water vapor in the atmosphere, and the movement of ocean currents. By using these equations and inputting data such as temperature, precipitation, and greenhouse gas concentrations, scientists can simulate the current climate and make projections about future climate change. One of the main applications of climate modeling is in projecting future climate change. Climate models can be used to make predictions about how global temperature, precipitation, and other climate variables will change in response to increasing concentrations of greenhouse gases. These predictions are based on various scenarios, such as different levels of greenhouse gas emissions, and they help policymakers and organizations to understand the potential impacts of climate change and make decisions about how to respond. Another important application of climate modeling is in understanding the natural variability of the Earth's climate. Climate models can be used to simulate past climate conditions, such as during the last ice age or the medieval warm period, and to understand the causes of these changes. These simulations can also help to understand how the Earth's climate system responds to natural forcing factors, such as solar radiation and volcanic eruptions. In addition, climate modeling is also used to understand the interactions between the different components of the Earth's climate system, such as the atmosphere, oceans, and land surface. These models can simulate the movement of heat and moisture between the atmosphere and oceans, the exchange of gases between the atmosphere and vegetation, and the feedbacks between different components of the climate system. By understanding these interactions, scientists can better predict how the Earth's climate will change in response to different forcing factors. In daily life, climate modeling has a wide range of applications, from informing decisions about how to adapt to and mitigate the impacts of climate change to understanding the potential impacts of different land use and energy policies. For example, climate models can be used to predict changes in precipitation patterns and temperature, which can help to inform decisions about irrigation, water management, and crop selection. Climate models can also be used to predict changes in sea level, which can help to inform decisions about coastal zone management and infrastructure planning. In addition, climate modeling also plays a crucial role in the field of energy and natural resource management. By simulating changes in temperature, precipitation, and other climate variables, climate models can be used to understand how energy demand will change in the future and to inform decisions about the types and locations of energy infrastructure that will be needed to meet this demand. Additionally, climate modeling also plays a role in helping to understand the regional and local impacts of climate change. Regional climate models, RCM, are high-resolution versions of global climate models that can simulate the climate of specific regions at a higher level of detail. These models can be used to make predictions about how climate change will affect specific areas, such as changes in temperature, precipitation, and extreme weather events. By understanding the regional and local impacts of climate change, organizations and communities can better prepare for and adapt to these changes. Math also plays a critical role in the field of paleoclimate research, which uses models to understand the past climate of the Earth. This includes reconstructing past climate conditions, understanding the processes that controlled these conditions, and reconstructing past atmospheric CO2 and other greenhouse gases levels. These studies help to understand how the Earth's climate has changed in the past and how it is likely to change in the future. Furthermore, climate modeling has also been used to predict the impacts of climate change on various sectors, such as agriculture, forestry, and fisheries. For example, models can be used to predict how changes in temperature, precipitation, and other climate variables will affect crop yields, vegetation patterns, and fish populations. By understanding these impacts, organizations and communities can make decisions about how to adapt to and mitigate the impacts of climate change on these sectors. In daily life, math is also used in weather forecasting apps and websites, which provide individuals with real-time weather information and alerts. These apps and websites use mathematical algorithms to analyze data from weather sensors and make predictions about upcoming weather conditions. They also use mathematical models to create visualizations of weather data, such as radar images, which can be used to understand the movement of storms and other weather systems. Climate modeling and weather forecasting are related but with different focus and purposes, yet both use math to analyze and predict the atmosphere's behavior. In conclusion, math plays a vital role in the field of climate modeling, and it is an essential tool used to understand the Earth's climate and the potential impacts of climate change. Climate models use mathematical equations to simulate the behavior of the Earth's climate system and make predictions about future climate change. These predictions inform decision-making on mitigation and adaptation strategies and understanding of past climate change. Additionally, math also plays a role in understanding the regional and local impacts of climate change in paleoclimate research, predicting the impacts of climate change on various sectors, such as agriculture, forestry, and fisheries, and in weather forecasting apps and websites. It is used to analyze and predict the behavior of the atmosphere and help individuals and organizations to make informed decisions and take appropriate actions to protect their health and the environment.